All right, this is Chapter 12, Section 5, Geometric Transformations. And our learning objective is to transform geometric figures using matrix operations. A change to a figure is a transformation of the figure. The transformed figure is the image. So transformed figure is the image. The original figure is the pre-image. In the solvent, the red figure, this guy right here, is the pre-image. The blue figure is the image. All right, so let's see how that applies to us. How would you translate the kite image A prime, B prime, C prime, D prime to the pre-image A, B, C, and D? So to go from B to B, so we would take A prime, B prime, C prime, and D prime, and we would take their x coordinate, so wherever we are on the x-axis, and 1, 2, 3, 4, 5, 6, 7, 8, minus 8. And then wherever we are on the y-axis, 1, 2, 3, 4, 5. We take whatever our y-coordinate was and minus 5. So otherwise that would look like if you go x and y, so I'd go minus 8 and minus 5, or plus negative 8 and negative 5. However, so let's look at B. A pentagon has a vertices 0, negative 5, negative 1, negative 1, negative 5, 0, 1, and 3, and 4, 0. Use matrix addition to translate the pentagon 3 units left and 2 units up. So let's write so this is for B, our pentagon. So we'll call this A, B, C, D, and E. So if you go A, B, C, D, and E, then you have x and y. So you go 0, negative 5, negative 1, negative 1, negative 5, 0, 1, 3, and 4, 0. And we're going to translate that 3 units left. So to move left, I minus 3. And 2 units up. So I take the y and I'm going to go 2 units up. So then I get negative 3, negative 4, negative 8, negative 2, and 1. And then I get negative 3, 1, 2, 5, and 2. So that's the answer to B. All right, so let's look at dilations. So you enlarge or reduce a figure with a dilation. It otherwise keeps a figure the same shape. You use scalar multiplication to dilate a figure with center of dilation at the origin. Thankfully, in this book, dilations have their centers at the origin. So we're always going to start from the origin, which will make our life tons easier. Okay, so if we have this little triangle, this black one here, which is at negative 1, 0, 3, 2, and 2, negative 1. We multiply all those items by 2, and it will double the side length of each of our triangles, which if we're dilating at about the center, it'll be -2, 0, 6, 4, and 4, -2. All right, so let's do that. Actually, I don't need a graph to do that. You're to enlarge a picture by a factor of 2. The pre-image is 5 inches by 3 inches. Actually, I do want that graph. Write a matrix of coordinates of the pre-image vertices. Make one vertex at 0, 0. So I'm going to put the points on our graph. So if for sure one vertex is 0, 0, it's a rectangle, so it's 5 inches by 3 inches. So I'm going to go over here, 1, 2, 3, 4, 5, 2, 3, 5 inches by 3 inches. So here's our original picture and of the pre-image. So for A, the matrix would be, so if this were A, B, C, and D, so it would be 0, 0 is our first coordinate, 5, 0 is our second coordinate, and 5, 3 is our third coordinate, 0, 3 is our fourth coordinate. What are the coordinates of the vertices of the image? Show the multiplication that you use for the dilation. So let's do B over here. You are to enlarge the picture by a factor of 2. So I'm going to take all these guys and multiply it by 2. And when I do, I get this. So let's find where that lives. If this is, so we still have 0, 0. We now have 10, 0. And then we have 10, 6. And then 0, 6. This is A prime, B prime, C prime, and D prime. Oh, it's huge, man. What are the coordinates of the vertices of the image? Show the multiplication that you used for the dilation. You enlarged the picture by the factor of 2. What factor did you increase its area by? Well, this guy had an area of 3 times 5. And then this guy has an area of 6 times 10. So you increased by a factor of 4. Boop. All right, let's talk about rotation. A rotation turns a figure about a fixed point. A fixed point is the center of rotation. You can multiply a figure's vertex matrix by a rotation matrix to find the vertices of the rotation image. In this book, rotations are called counterclockwise about the origin, and counterclockwise it goes like this, that way. The matrix 0, -1, 1, and 0 rotates a figure 90 degrees. A 90-degree rotation followed by another 90-degree rotation is 180 degrees rotation. And then rotate another 90 degrees for a 270 rotation. So make sure you put this down. Rotation matrices, 90 degrees is you multiply by 0, -1, 1, 0. 180 is -1, 0, and 0, -1. 270 is 0, 1, and -1, 0. And 360 is the identity matrix, because you should get all the way around to where you were before. All right, let's see how that applies here. Rotate the triangle with the vertices -3, 0, -4, 4, and 1, 1. So I multiply that by my 270 matrix, which 270 is here, so 0, 1, -1, 0. And I had to do do I put it on the right-hand side or the left-hand side? And I put it on, this is a 2 by 2, and this is a 2 by 3. So I should get out a 2 by 3. So when I do this multiplication, I get out 0, 4, 1, 3, 4, -1. Or my A coordinate is 0, 3. My B coordinate, I'm sorry, this is D, E, and my F coordinate translate to these guys here. All right, that was rotation, so let's talk about reflection. So if we want a reflection across the x-axis, I multiply by this matrix. If I want a reflection across the y-axis, I multiply by this matrix. If I want a reflection across y equals x, I multiply by this matrix. And if I want a reflection across the line y equals -x, I multiply by this. So let's see if we got it. We are going to graph, it says reflect the quadrilateral with these vertices across the indicated line. What are the vertices of the image? Graph the pre-image and the image in the same coordinate plane. So let's plot these points together. Let me get a pen. So E is 1, 1. F is 3, 1. G is 6, 4. And H is 1, 3. So it's a nice little kite looking shape. All right, so let's do our multiplication and find the reflection across the x-axis. So let's make our so we got 1, 1, 3, 1, 6, 4, and 1, 3. I'm going to multiply that by my x-axis one. So this is 1, 0, 0, -1. So then I come over here and I'm going to do some matrix multiplication. I got my 2 by 2 and my 2 by 4. So this is 1, 0, 0, -1. And then the other guy is 1, 1, 3, 1. 6, 4, and 1, 3. And my result is 1, -1, 3, 0, 6, -4, 1, -3. And just to remind you, we're reflecting it across the x-axis. So if I were to fold this paper in half, it should give me a nice mirror image here on the bottom. So we got 1, -1, 3, 0, 6, -4, and 1, -3. -1, 0, 6, -4, and 1, -3. 1, 6, 4, 1, 3. So it reflects it across the x-axis. Alright, I must have put something in my calculator wrong because it gave me an incorrect coordinate. So now that I have the correct coordinate, I'll change my picture a little bit. So if I have -1, sorry, 1, -1. Oops, this is -3, -1. It's right here. There we go. And then 6, -4. Now we have a nice mirror image across the x-axis. Okay, we're going to do this one more time, but across the y equals x. So instead of 1, 0, 0, -1, we're just going to go 0, 1, 1, 0. So when I do that in my calculator, I get 1, 1, 1, 3, 4, 6, and 3, 1. So let's see how that looks. So I got 1, 1, 1, 3, 4, 6, 3, 4, 6, and 3, 1. So if I look, where is the line y equals x? So it reflects it across that one. So good times. All right, and that's it.